Okay, welcome to this question. The question is as follows. To put the following sentence in a binary search tree with the first word as the root node. So the first word, which is we, is the first thing we write down. So let's write it down. We is the first word. Now our binary search tree. Now this is how a binary search tree works. We get 1, 3, 5, 4. This is the values that we get. Now, the binary search tree starts at 1, then goes further to go to 3. Now it goes further to 3, and then because 3 is greater than 1, it goes to the right side. Now we go to 5. 5 is greater than 1. 3 is also greater than 1, so 5 should go to this side. Now 4 is greater than 3, but 5 is already there, so we put 4 on this side because it's less than 5. Now we got 2 there. 2 is greater than 1, but it's less than 3, so we can put 2 on this side. And this is the binary search tree for this values 10. Okay, so this is basically the same principle, but we use alphabetical order. So the second word is all. All starts with an A, so it goes to the left side of we. Now the third word is look. Look is less than we, so it goes to that side, but it's greater than all, so if it's greater than all, we put it here. Look. Now forward is also greater than all, but it's less than L, so it goes to this side. We all look forward. So let's cross the words that we use, so it's easier to read. So now the next word is 2. 2 is less than we, greater than all, and greater than L, so it goes to that side there. 2, and then we have A. A by itself, it's like having a 0 next to it, so it's less than all. We put A. We put the A there. And now we have summer. Now summer is less than we, greater than all, greater than look, so it should be on this side. Now in alphabet it's S then T, so summer goes to this side. And we cross it out. Now the next word is holiday. Holiday is greater than forward, but we don't have space. So let's so I auto-delete it to make it work. So holiday goes here. We cross that out. Now after it's less than we, that means that it should go here after the A. Now the is less than we, greater than all, greater than look, less than 2, but greater than summer, so it goes to this side. And there's the. Now we got exams. Exams are less than we, greater than all, less than L, and less than F, so we got a space here to put it. Exams is there. And this is the answer to this question. You start from the first word as it tells you. It's the root node. and then you just work your way down. And this is how to solve a binary search tree with a given sentence. Okay, so now this question is a Turing machine defined by quintuplets, which are given on this side. For each of the initial tapes, determine the final tape. So we gotta find where it ends. So basically, this is a tape. We gotta give the final tape. When M halts, assuming it starts in the leftmost known blank position, state 0. So that'll be state 0. We've got to use the quintuples to check. So if you did not know yet, this is the initial pattern. Then this is the next state. This is the current change. So the 0 will change to a 0. Or the 1 will change to 0. And this is where it moves to. It's either left or right. So let's start. We start with S0, and we can see that there's two S0s. One of them starts with a 0 and the other one starts with a 1. We want the one that starts with a 0. So this one starts with a 0, and then it goes to S1, and we'll change the current state to a 1. So let's do this. We put a 1 there, and that's the new state of the tape. And we move right to become S1. So we move right to become S1. Now we're in the state of S1 and the current state of 1. So the state S1, current value 1. This means we gotta move right. I move right, change the value to a 0. So this one becomes a 0. And we still are in state 1, so it's S1, but we're different now. So we are S1 at 0. This will make the 0 turn into 1, and we're not going right anymore, we're going left to S2. So we're S2 and we're at 0, not 1. This is the current state. So S20 will send us back to S0 with the value of 0. So the 0 stays 0, and we go back to the left again and return to S0. Okay, so we're in S0. S01 tells us that we gotta go back to the right and make that value 0. We go to the right to S1. Now S1 0 tells us to go back to S2, make that value 1, go back to S2, S2 where the value is a 0. So S2 0, S0 0. So we won't change anything, and it's telling us to go to the left. So that means we finished basically, because we cannot go to the left anymore. So at the end of the day, we get a new tape that is 0 1 1 0 1 1 1 0. This is the new tape. So as you can see, doing this, we get 0 1 1 0 1 1 1 0. Determine the final tape. This will be the final tape. Now let's do part II then and see what we get. Now for this part, there's a difference. Difference is that there's blanks, so we do not count these. We count from 1, so 1 will be our S0 initial state. I'm gonna find out where S0 is 1, so that one there, and we gotta move to the right, changing the value towards 0, and the state to S1. So the state's S1, 0. That means we're going to move to the left. S2. The current value changes to 1. And now we are in S2. S2 is at 0. And when S2 is 0, we move to the left to S0. So we move to the left, but the left is a blank, so that's where we stop. Now that means the new tape, final tape, is BB011110B, and that is our final tape, BB011110B, and that's the answer to this question. See you guys in the next video.